Hello everyone, James Lyne here, SANS Chief Technology Officer, and a pleasure to be here for one of the keynotes opening today's fantastic lineup of speakers. It's a real pleasure to do events like this, to find so many of you enthusiastic about learning new cyber skills and being able to contribute to this industry that really has this wonderful job of making life hard for cyber criminals. Now, it's always challenging to put together a talk for an audience like this, because there are going to be people listening with very different levels of background expertise. Some of you may be really quite practiced and hobbyists already. Some of you might just have a growing interest. So I'm going to show you a variety of interesting, different, cool techniques, all that center around using some of the tools built into your computer, kind of simple concepts that are surprisingly powerful. And this is a running theme in cybersecurity. Yes, there are amazing tools. Yes, there are advanced low-level exploits to be written. But actually, a lot of the time, it's about problem solving. It's about applying a lot of the tools that we have in front of us in creative and new ways. So I'd like to very quickly show you 5 cool things and use them in ways you may not have considered before. Again, some parts you may find more or less accessible, but remember, this talk's recorded, so you can go back over this and try it yourself on your own system. So let's dive into a first one here, and I'm going to be using the command line. Command line skills are awesome. They help us solve problems at great pace, and a little later, I'll show you how computers can crack passwords at a terrifying rate, solving problems that we as humans would find difficult. Over on the left-hand side here, I actually have an Ubuntu Linux system, and I'm running as root, very privileged. And over here on the right, I have my local system command line. So these are different systems. If I type ifconfig over here, we can see the IP address of this system. And note, by the time you get around to seeing this talk, this IP address is no longer going to be connected to this system. So no poking my assets, please. Well, let me show you a first cool little trick with a tool called Netcat. There's also a more flexible version you may run into called SoCat. Now, Netcat is a pretty neat utility that lets us do things like transfer files around or set up basic servers. So, for example, I could say set up a server, netcat-l-p8080, and over here I could connect to, let's get that IP address again, that port on 8080 and send a message. And notice it's connected. This is over TCP, and I can send a message back. So that's neat. I have a very simple server now running between these two systems. Well, there's all kinds of cool things we could do with this. For example, let me make over here a file called super.txt and say this has got important stuff, and I'm going to start my server again, and now I'm going to do netcat and feed in super.txt, and notice it's transferred the content across. So here we're just using a little shell redirect to enable me to do that. Well, if we could do that, we could transfer other things. For example, I could have this server send a copy of bin ping, that's the ping program, to anyone that connects. So let's do that. And over here, I'm going to output this to a file called ping2. So we hit enter, we finish, and let's just see if these files have been created. Let's do file ping2, and we can see ping2 exists. And note the file command here is cool. It shows us the type of file that this is, and it says it's a Linux executable. If we want, we could check if these are the same. Let's use MD5 to do that. So this is a hash, and if we run MD5 sum over here, and then over here it's just MD5 as follows, we can see that the file we've transferred matches. So this is a kind of integrity check to validate the data's the same. So that's cool. We're now transferring files around between these servers. But what seems like neat little functionality can get dangerous quickly. Let's use this to make a backdoor. Now, if you haven't run into this before, the idea of a backdoor is something you can connect to that enables you to get onto a system and to be able to execute commands. It's something attackers often want to do. They initially exploit in some way via a web application or similar, and they want a backdoor so that they can probe the system a little bit more and look at the data. So I'm going to use a copy of Netcat Traditional, and this includes some extra dangerous capabilities. In fact, the one we're interested in is -E, which says when someone connects, execute this program. Well, it could be -bin-ping, as before. So now I'm going to connect to the server, and it outputs destination address required. That's the ping program if you just run it by default. Here we go. Bin ping. But what if we were to run a shell? As in what we use to execute commands. Well, now we have a backdoor. Notice here I'm the root user on this system, and over here I'm main user on a completely different system. I'm going to connect, and it looks like nothing's happening. But now, if I type ls or id, I am the root user, and I'm actually looking at the file system of this computer over here. This is a backdoor. If an attacker had managed to get this command executed on this system, I can now connect and do whatever I want. I could go to etc and cat files that might be sensitive, reading about users on the system, and so on. Now, be very careful with this type of functionality. I mean, I've just very purposefully opened up a backdoor onto my system. And of course, I connected to it, so I control the connection, but there was no authentication here. Anyone that found that port could have connected to it, which unfortunately I've seen happen in a few breaches where attackers intended to have control and inadvertently gave it to someone else. So here's a good example of a simple tool for file transfer and building little servers. Useful in scripting, but also very dangerous if used the wrong way. If you haven't used the command line before, that was probably quite quick and fast, but don't worry, we're going to move on to something a little bit different next. But first, espresso break. Okay, so now back to it. I want to show you a bit of a different direction here. I'm going to show you a challenge in CyberStart. Now, some of you may have played CyberStart through a program already. I suspect there's quite a few of you here who have. It's got some easier challenges and it's got some way harder challenges. Now, if you haven't, you can head over and create a free account and get access to a bunch of challenges in this intern base here, as well as some spoilers, some walkthroughs of interesting kind of initial problem solving and hacking techniques. So check that out. But I want to show you an interesting problem here of when people implement security on the client side, that is our browser, rather than on the server side where we don't have control. And I'm going to do that with one of these challenges. In this case, this is a super fun one, the Spinlock Extreme tool. Now, this is a great chance to draw attention to some of the tools that we have all around us every day that maybe we're not making the most of. Most web pages are built from HTML, CSS, and JavaScript, languages that are used to render interfaces like this. So all I'm going to do, where I want to figure out how to unlock this thing, is right-click and say Inspect Element. Now, depending on your browser, that might look a little bit different in Safari or Firefox or Chrome, but they all have this feature. And it's brought up the developer tools where we can look at the code behind this stuff. So this is pretty interesting. Let's have a little look through all this code. And one of the key things we do in cybersecurity is looking for stuff we do understand in the middle of stuff we don't. Don't get fazed by details you don't understand. Well, here we see some messages left by a developer. Remind users of the number of degrees to use to unlock. Set new degrees to unlock all circles between -81 and -4. Well, it's very helpful. Thank you, Mr. Developer. I've actually seen in some cases breaches where a comment was left like, to do remove XYZ admin account. So there's 3 circles, 1, 2, 3, and there's a function here, a piece of code that's designed to turn the circle. So we need to get 1, 2, and 3 between -81 and 4. Well, in our browser tools here, this is client-side code, we can actually run this stuff. So we can run the turn circle function. So let's do that. Let's say turn circle, circle 1, and let's make it -80. Okay. Well, that's interesting. The thing stopped moving, so something happened. -80 is indeed between -81 and 4. Let's move 2. That's interesting. That's moved 2. And 3. And there we go. We've unlocked our lock. Now, authentication systems don't often look quite as cool as this. But here we have the idea of logic that looks secure to the user, but depends too much on the browser that you control. This mistake turns up in Internet of Things devices and all kinds of technology that we need to secure. So this is actually a somewhat realistic scenario. And this demonstrates even our browser, before you get near any kind of specialist cybersecurity tools, can have a role to play. It's about problem solving. Now, if you enjoyed that, remember you've got the field manual here that has a walkthrough of each of these challenges, if you want to listen to me solving a few more of them, and you have an opportunity to play a few more of these. And some of these hard ones in level 3 are pretty tough, so have a go if you haven't already. Okay, another espresso break, another cool thing. Be right back. You know, the more of these I have, the more interesting the talk is going to get. It's a scientific probability. Okay, so we've looked at some browser tools. We've looked at how some command line tools can be used to transfer data or even create a backdoor. So sometimes very inane tools can actually be incredibly useful to cybercriminals or to security professionals. A lot of things have different use cases depending on how you apply them. You're also hopefully seeing that foundational IT skills can also play a huge part in cybersecurity. Well, let's look at an interesting example now of things that computers can do that humans would really struggle with. I've got here a file called secret.zip. It's an archive file and it's password protected. I'm going to run the file command on it again, and it says it's a zip archive. So I'm going to do unzip secret.zip. And it's protected with a password. The data in it is encrypted, and it's pretty strong encryption at that. So I could start guessing the password. I could start researching what someone may have used. There are some common patterns and permutations. But what I'm instead going to do is actually ask the computer to do a lot of the work for me. The first thing I'm going to do is go and grab a word list. And this isn't a particularly fantastically vast word list, but I'm going to go and let's take a copy of this. I'm going to go download this word list to this system. There we go. I use the wget command. That's a command line utility that lets me download a file from the internet rather than using a web browser. This word list is constructed of passwords that people have used in breaches, but used on accounts and servers before that have been breached. So it's built by real-world use cases. And there are even bigger word lists out there. And that can be scary because sometimes what seems like a secure password is actually already published and known. And it's not a particularly secure password if it's in a dictionary. If we had to guess super secure password 2022 ! One by one, character by character, it would take a really long time. But if it's in a list of words a computer can try, it can go surprisingly quickly. So let's use a tool called fcrackzip here. And this tool is designed to brute force or dictionary attack a zip file and to look for passwords that might match. So let's just look at the available arguments for it. And let's have a look at a benchmark here to see how many attempts this computer could go through per second compared to a human. So let's do oh wow, really can't type today. fcrackzip-b. Okay, so that is a lot of passwords per second. Now think about that in terms of all those published passwords you might be reusing or a nearby version, and that speed. And this is before any clever optimization. A human could maybe, if they were phenomenal, get to a password a second, and yet a computer can go so much faster. So let's run the file command on this word list. It's a zip file, ironically. So let's do wordlist.tx_. Now we have the word list. And if we look at it, we can see it's got lots of words in it. Okay, so let's run fcrackzip now with the right arguments to have it attempt to break this password. I'm going to be using dictionary mode, and I'm going to be asking it to try to unzip each of these attempts to validate that it really works on the archive. I'm looking for passwords from wordlist.txt, and I'm doing it on secret.zip. Okay, so I'm going to leave that running, and at that speed, I mean, it should get through this word list pretty quickly. And it's trying all these combinations one after the other, and in no time at all has recovered the password. This is a password. Now, some people would say that's not bad. I mean, yes, it could have some capitals and some numbers, but it's quite long and it does have symbols in it. There are lots of people out there that wouldn't expect a password like this to be found so quickly. But that's the power of a computer and automation. And of course, whilst we're using a tool here, in the future, you might build a tool that works with some special data structure or archive to demonstrate a similar problem. Okay, well, let's check it actually works. Unzip secret.zip, put in the password, and we get secret.txt as a result. So yeah, call to action, protect me. New to cyber, folks. So this is a great demonstration of how computers can solve problems when directed correctly or attacking a problem the right way that humans can't. And it also shows why password complexity and securing your accounts is really, really important. Computers can do things that the average user just wouldn't think of here. So hopefully that was eye-opening and it makes you think more about your password choices. And there are lots of great resources, including some fantastic SANS webinars on how to make better security choices here. Maybe as a bit of an extra assignment after this, you could help your friends and your family choose some passwords that would be a little harder for a tool like this to be able to guess on a file or an account. All right, I'll show you one more cool thing, for which, once more. Okay, one last fun thing here. So here we have a web application, and I've connected to it, and it shows a session ID value on the end here of 1. Oops, browsed off to Yahoo. So one of these IDs might do something interesting. This happens a lot with web applications. We're given tokens or pieces of information that are tied to our identity. I want to show you very quickly a continuation of this theme that computers can do interesting things at higher velocity than we can. So let me grab this URL and just show you the tool curl. Curl enables me to grab a website URL. Now notice here it's not working immediately because I have got a slash missing. I need to escape this question mark. So when I use curl here, it goes and grabs the web page, and you'll see welcome to the session authenticator BR, exactly what we see in the browser. Being able to use a command line tool like this is really, really useful for scripting, because now from the command line we could try 6, 7, 10 to see if anything interesting happens. Well, let me teach you the value of basic scripting and programming. And don't worry too much if you don't immediately follow all the syntax. what I'm hoping for you to extract is the value of being able to write your own very simple programs to solve problems. I'm going to write a loop. I'm going to say for I in 1 to 250. So that's 250 times we're going to loop through. Do. And then we're going to say echo I. So it'll tell us which attempt we're working through. Actually, let's make it trying I. And the idea is it should substitute in the number of each run into this output. Then we're going to put in our curl command here, but we're going to replace our value with I at the end here. And then we'll do done. Okay. So look at this. It's iterating through, which is really cool, and it's trying each of these values and printing the results to the screen. Well, this is great, but I don't want to read all this rubbish. I'm looking for something different to welcome to the session authenticator. So let me just customize my program a little bit and show you another great utility called grep. Grep lets us search for content or exclude content. So here I'm going to do grep -v welcome, which says print to the screen anything that I already anything that doesn't match that welcome. So anything else, if you will. I'm also going to add S for silent here. So here we go. Now we can see it's no longer printing the text, but it's still trying. It's going to this web page again and again and again, trying these different values, working through it. Of course, this is all showing up in the web server log. So any of you listening who are interested in future defensive practices, think about the rules that you could write to detect this type of enumeration behavior. And here, I'm going relatively slowly. Of course, you could write this program in a faster language. You could use Python or even C if you wanted to go really quickly to be able to enumerate this at very, very high speed, which is, of course, for defenders, even more likely to get you caught. All right, so going through, not seeing anything interesting yet. All right, so let's have a little look at our script here and see if there's anything that we are missing. So we're trying I, curling for that. That looks good. There it is. Look at that. We go here. I've got secure ID. Well, the original address was session ID rather than secure ID. Turns out if you hand it completely the wrong variable, not good things are going to happen. All right, so let's let this go through again. And this time, let's see if we get to any interesting results. Now, whilst this is running, note here this session ID is a simple number. Of course, in good web applications, it'll use more complex schemes, looking at some kind of randomly generated ID that's much harder to predict. But sometimes those systems are flawed. Perhaps in the future, you'll be writing a tool that enables you to be able to predict the next value or find ways to weaken the probability of which one a web application will select. It's exactly the type of work that we do in cybersecurity to then be able to remove those things from the arsenal of tools that bad guys could do. So here we go. 167, administrative functions unlocked. So let's go back to our web browser here. Go to our session ID that I mistyped and make it 167. And there we go, administrative functions unlocked, and we get a lovely XKCD as well. Now this may be a simpler example, but it shows you the power of scripting and being able to write your own programs. So let me wrap up here in my summary very quickly. And rather than having a summary slide, I actually have it all prepared very nicely in hex format here. Basic scripting can take you really far. Use of the command line. Take time to play and overcome problems. There's so many amazing tools out there, but the best security people learn how to get creative and come up with their own solutions, maybe using those tools and extending them. For those of you listening, there are so many amazing career paths ahead, from forensics to being a digital Sherlock Holmes to finding flaws in web applications or writing low-level exploits. And there are new roles appearing all the time, like in the cloud. But remember, Everyone feels daunted by this stuff. There's so much to learn. And sometimes you watch a talk like this and think, how do you ever remember all of that and do it so quickly? Practice. Every one of us presenting, any one of us world-class practitioners that are helping businesses thwart cyber attacks started right where you are, confused about some of this stuff. Build your own lab, try these walkthroughs, listen to more talks, be persistent. You can do it. And if you want some more practice, as I mentioned before, feel free to go and have a go at some of the free challenges with a free account at CyberStart, like that Spinlock one that you now know how to solve. I hope you have a fantastic rest of day. I know you've got an amazing lineup of speakers. Catch you soon, and good luck.